Welcome to this lesson. We are going to focus on graphical interpretation of the lens formula. So we will have three cases. The case whereby we look at a graph of 1 over v against 1 over u. Now from the lens formula we know that 1 over f is equal to 1 over u plus 1 over v. So if we rewrite this formula such that we have in the form, we write this equation in the form y equals to mx plus c, then 1 over v is going to be equal to, so we take 1 over u the other side, so it becomes negative 1 over u plus 1 over f. Hence, the slope of this graph is negative 1, and 1 over v is the intercept. So it will be a graph that looks like the one shown here, and from there we can get f because any intercept will give us 1 over f. Now, case number 2. If we draw a graph of 1 over v against u plus v, then you will realize that now if we manipulate the formula, the lens formula, that is 1 over f equals to 1 over u plus 1 over v, then we are now going to have the LCM of u and v is uv there. As you can see, u goes into uv v times, and then v goes into uv u times. So then we are going to have uv is equal to u plus v into f. Now, in the form y equals to mx plus c, you will realize that uv is equal to f into v plus u plus v, then plus 0. Thus, the gradient is equal to f and uv intercept is 0. That is why this graph is coming from the origin. So it is a graph of a straight line passing through the origin. Case number 3 is whereby we are having a graph of u against 1 over m. So in this graph of u against 1 over m, again we start from the lens equation, which is 1 over f equals to 1 over u plus 1 over v. So u over f equals to u over u plus u over v. Now we know that m is equal to v over u. The moment we have u over v, that means it is now 1 over m, the reciprocal. Therefore, if we now multiply through by u, then we are going to have u to be equals to f over m plus f, implying that f, if we make this f the subject of the formula, then f equals to slope and u is the intercept of f. Now it is a straight line that cuts the vertical axis at f, as vertical axis at f, yes, and at -1, I mean. So try this exercise. Interpret a graph of m against v and v against m. Apart from that, we also can determine the focal length of converging lenses by various methods. So method 1, you focus on a distance object. So the apparatus needed, you need a meter rule, lens, a lens holder, and a screen. So you mount, as shown in this diagram here, mount a convex lens on the lens holder and fix the meter rule on the bench using plasticine, as shown in this diagram. Then place the white screen at one end of the meter rule. Move the lens to and fro along the meter rule to focus clearly the image of distant object like a tree or a window frame. So measure the distance between the lens and the screen. Then you record your focal length. You should note, however, that the distance between the lens and the screen gives a rough estimate of the focal length of lens. This is because parallel rays from infinity are converged at the focal point on the screen. So method 2, using an illuminated object. So when you're using an illuminated object and plane mirror, so this is called reflection method. So the procedure here is you set the lens in its holder with a plane mirror behind it so that the light passing through it can be reflected back as shown. So you can see this diagram. So we have the candle there, we have the screen with cross wire, and then we have got the mirror put behind the lens, as you can see the diagram there. Now adjust position of the lens holder until a sharp image of the object is formed on the screen along the object itself. Record the distance between the lens and the screen. So that distance again gives us focal length. So you should however note that under these conditions, rays from any point on the object will emerge from the lens as parallel rays. So they are therefore reflected back through the lens and brought to focus in the same plane as the object. The distance between the lens and the screen now gives focal length. Method number 3, using a pin and a plane mirror, also called parallax method. So you set up the apparatus as shown. We have the retort stand, boss and clamp, and then the cork is attached at the clamp, and to that cork we have a pin. So we have got a lens, and then it is put over a mirror. So adjust the position of the pin up and down till its tip is at the same horizontal level as the center of the lens. A position is found for which there is no parallax between it and the real image formed. For best results, attention should be given to the tilt of the plane mirror so that the tip of the image of the object pin appears to touch at the same level as the center of the lens. The distance between the pin and the lens will then be equal to the focal length of the lens. So what is power of lens? This is measure of the refractive property of lens, and it is given by 1 over focal length. The unit of power of lens is diopters, abbreviated by letter